Have you ever wondered how things in our world can change so incredibly fast? I mean, we're talking about explosive, practically unstoppable change. Well, today we're diving into this explainer to look at the mathematical engines behind those kinds of phenomena, the multiplicative power of exponential growth and decay.
Here's our quick roadmap for today's lesson. First, the power of fast change. Second, the exponential formula. Third, growth and decay examples. Fourth, your homework challenge. And finally, number 5, education paired with morality.
Section 1. The power of fast change, moving beyond addition.
Think about it for a second. How exactly does a virus manage to spread to thousands of people in just a matter of days? Or, on the flip side, how does a well-managed savings account suddenly seem to completely balloon in value after a couple of decades? To really understand this, we have to contrast linear change with exponential change. Linear change, well, that's what we're mostly used to in everyday life. It's just adding the same amount over and over. You know, you earn $10 an hour, you work another hour, you add $10. Simple. But exponential change? That's a whole different ballgame. That is multiplying by the same number each time. The absolute secret here is that you aren't just adding anymore, you are compounding. A virus spreads by doubling or tripling its hosts. Your savings account earns interest on the interest. We are stepping completely out of the slow world of addition and diving headfirst into the world of multiplication.
Okay, moving to Section 2, the exponential formula, the mechanics of rapid change.
Here it is, the master key to modeling all this fast change. Y equals A times B to the power of X. Let's break this down so it's crystal clear. A, right there, that's your starting value. It's the exact amount of money you open your bank account with, or maybe the number of bacteria cells sitting in a petri dish right at the very beginning. Then you have B. That's your growth or decay factor, which is really just the base number you're constantly multiplying by. Are you doubling your money? Then your B is 2. Are you losing half your mass? Then B is 0.5. And finally, X. That tiny little exponent up there, that's your number of time intervals. How many hours, days, or years have actually passed? Because X is an exponent rather than just a simple addition sign, that is literally what gives this formula its explosive power. So the really cool thing is that this one single formula beautifully handles both directions of fast change. If your B value, your multiplier, is greater than 1, you get exponential growth. The numbers just get bigger and they get bigger fast. 2, 4, 8, 16. But if your multiplier is less than 1, say it's a fraction or a decimal, you get exponential decay. The total shrinks rapidly. 100 drops to 50, then 25, then 12.5. The mechanics behind the scenes are exactly the same. It just depends entirely on whether you are multiplying by a whole number or a fraction.
Section 3. Growth and decay examples, seeing the math in action.
It's time to take this out of abstract algebra and apply it to the real world. Let's model some bacteria growth. Say a scientist starts with just 5 bacteria cells, so our starting A value is 5. Now, this particular strain of bacteria doubles every hour. That makes our B value 2. Let's run the formula. Hour 1, boom, 10 cells. Hour 2, 20 cells. Hour 3, 40 cells. You can actually visualize how the steps between the intervals are getting much, much larger. It's not a straight, flat progression. The curve is accelerating upwards.
Now, let's look at the reverse process, ice melting decay. Imagine you've got a heavy 16-kilogram block of ice. Because of the room's temperature, each hour it retains only 75% of its mass. Think about that. It melts and loses 25%, meaning it keeps 75. So our starting value A is 16, and our multiplier B is 0.75. At hour 0, we have 16 kilograms. After hour 1, we're down to 12 kilograms. After hour 2, we're at exactly 9 kilograms. This brilliantly illustrates how decay works. The drop is mathematically the steepest right at the very beginning when there's more ice to melt, and then that loss gradually tapers off as the block gets smaller and smaller.
You know, you don't always need a word problem to spot this pattern. You can see it hiding right there in raw data. Check this out. As our time intervals go up, step by step, 0, 1, 2, 3, our output jumps from 3 to 6 to 12 to 24. They definitely aren't going up by a set additive amount. From 3 to 6 is a difference of 3, but from 12 to 24, that's a difference of 12. Instead, they're being multiplied. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. The second you see that constant multiplication happening in your outputs, you instantly know you are looking at an exponential pattern.
And this multiplicative concept, it isn't just for science labs or finance. It applies to human populations and major historical movements as well.
The HeroesMart Academy curriculum, which provides the source material we're exploring today, highlights a fascinating example from the book of Acts, chapter 2, verse 47. It reads, "And the Lord added to their number daily those who were being saved." This is describing the early Christian church. What started as a tiny, isolated group didn't just grow linearly. It spread multiplicatively from person to person, community to community. It's a really compelling historical example of a small starting value, RA, experiencing an exponential growth factor, completely fundamentally changing the cultural landscape in a relatively short amount of time.
Section 4. Your homework challenge. Test your knowledge.
Okay, I want you to actively apply what we've just covered, because actually applying the math is where this stuff really locks in your brain. Here's your first question. Is the pattern 10, 20, 40, 80 linear or exponential? I'll give you a second. Look really closely at the relationship between those numbers. Did you guess exponential? If so, you are absolutely right. Why? Because we aren't adding the same amount each time. The gap changes from 10 to 20 to 40, but the multiplier, that is perfectly constant. 10 times 2 is 20, 20 times 2 is 40. That constant multiplier is exactly what defines exponential change.
Here are the rest of your challenges. I highly recommend you take a moment to try setting up the y equals a times b to the power of x formula for each of these yourself. Number 1, a population triples every hour, starting at 2. Just ask yourself, what's your a and what's your b? Number 2, medication loses 20% strength per hour, starting at 100 milligrams. Remember our ice example. If it loses 20%, it keeps 80%, so 0.80 is your multiplier. Number 3, a plant multiplies its size by 1.5 every day, starting at 4 centimeters. And number 4, a savings account decreases 10% monthly, starting at $500. Setting these up on your own is absolutely going to solidify your understanding of how to translate the real world into algebra.
And our final section, number 5, education paired with morality, the bigger picture.
Before we wrap up this explainer, let's transition from the raw mathematical mechanics to the foundational philosophy of the HeroesMart Academy's Godly Learners series, which actually provided the source material for today's math lesson. The curriculum operates on a very specific premise. Education without morality will hurt. The philosophy they're imparting here is pretty straightforward. What's the point of being highly intelligent or understanding complex, powerful formulas like exponential growth if a person continues to make choices that ultimately harm themselves or others? Think about it mathematically. Knowledge is essentially a multiplier, much like our b-value. If you multiply bad choices with high intelligence and capability, the negative impact grows exponentially. Their curriculum argues that education must be paired with a strong moral compass to truly benefit the individual and society as a whole.
The source material concludes its math lessons with a spiritual grounding, referencing Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. The curriculum notes that experiencing this peace is the intended outcome for those engaging with their educational content. It's an interesting reminder that true growth isn't always just about accumulating raw data and facts in our brains. For them, it's about cultivating a mindset that actively seeks wisdom and peace. And that leaves us with a pretty profound question to ponder today. As you exponentially increase your own knowledge and skills in life, what framework are you choosing to multiply them against? Thanks for joining me for this explainer, and keep learning.